Hello Math 8 students, this is continuing our end of year review. We're going to start with this quick pull, find the missing length of the right triangle below. Round to the nearest tenth if necessary. Go ahead and pause the recording until you have this done. Return to check your answer. Alright, let's go over this all together. What do I need to know in order to be successful with this problem? What do I need to know? Carter? Yes, so I need to know what information I'm giving and the labels that I would assign that information. Even more, there's a certain property that I know that you guys use. What should I know in order to do this problem? Joshua? Yeah, this is a Pythagorean theorem problem. When I'm talking about right triangles, that's the Pythagorean theorem. So let's begin with, what is the Pythagorean theorem? Esther? I am so happy that you said it the right way. Leg squared plus leg squared is equal to the hypotenuse squared. It's none of this A, B, and C stuff, right? We know it's leg squared plus leg squared equals hypotenuse squared. So now we can apply what Carter said. Let's label the information. Since I need to know which ones are legs and which ones are hypotenuse, let's do that. Let's start with this 5 yards. What is that, leg or hypotenuse? Leg. It's helping to form this right angle, so the 5 yards is a leg. Let's go with the 15 yards. What is that going to be? That's a hypotenuse. It is not forming the right angle. It is directly across from it. This one gets the label of hypotenuse. And the x is also helping to form that right angle, so this is also a leg. So leg squared plus leg squared equals hypotenuse squared. It doesn't matter which leg you put in first. So I'll go 5 squared plus x squared is equal to the hypotenuse squared, which is going to be 15 squared. It's a matter of simplifying. 5 squared is 25, plus x squared, which is equal to 15 squared, is 225. Trying to get x all alone, and x is being squared, and we added 25, so now we need to subtract 25. X is a little bit closer to being alone. I now have x squared, which is equal to 200. X isn't alone yet. What is the final step that I need to do to get it alone? Emily. It is squared, so if I square it again, is that going to help? Square root, yes, square root is the inverse of the square, so I need to take the square root of each side. The square root is what will undo that square, and that leaves me with x is equal to the square root of 200, which I did have 2 students enter that. That is mathematically correct, except for the fact that I did say round, which means if I'm asking you to round, we shouldn't leave it as x equals the square root of 200. Also, P.S., that should have been simplified. If you're going to leave it in a radical, make sure you're leaving it in a simplified radical. But let's just type in square root of 200. What is the square root of 200? And we get x is equal to 14.14. Give me a few more digits. 14.14 what? 214. Great. So let's talk about rounding. Let's go back to 2nd grade. Let's talk about rounding. First thing first, we need to round to the correct place value, and I asked you to round to the nearest tenth. That means the dimes, the tenths place, which means I need a digit here. And when I need a digit here, that means I look at its neighbor to decide what that digit is going to be. Is the 4 enough to make that one change? No. So if I'm rounding this correctly, it's 14.1 yards. Not 14.14, not 14.2. Make sure you know how to round and you are reading those rounding directions. That is going to be important on Friday's test. All right, let's continue on with our review. So in our last video, we reviewed the properties of exponents, and we also reviewed functions. We finished both of those sections, so now let's go back and let's review scientific notation. And then we'll finish up with reviewing Pythagorean Theorem, which we started with our quick pull, so that should go pretty easy. So let's review scientific notation. The first 4 problems, each of these numbers is in standard notation, and I want you to write it in scientific notation. 5 through 8, each of these are in scientific notation, and I need you to write them in standard notation. That is the most important thing. After that, we've got some calculations that we can practice as well. But let's just make sure that we understand what scientific notation is. I'm going to pause the video as students take 3 minutes to do whatever they can from these problems before we review all together as a class. So pause the recording and do what you can on your own. Ready, set, go. All right, 7,000 written in scientific notation. We remember with scientific notation, we need to have a significant figure that's between 1 and 10. We need something in the ones place, and it's okay if there's other decimals, which means the decimal place is currently here at the end, and I need to move it so that it's here. So it's going to be 7 or 7.0. I prefer 7.0, but I think other people will just show 7. That's where I want the decimal place to go, which means I need to move it over 1, 2, and 3 times. So that means it's 7.0 times 10 to the power of 3. Because when I multiply by 10, that moves the decimal place. And so when I multiply by 10 3 times, that means it's moved the decimal place 3 times. So 7.0 times 10 to the third, or 7 times 10 to the third. Either one of those is great. Any questions on that? Okay, so 35,000. This is where the decimal place currently is. I need it to get to here. That will leave me with 3.5, and 3.5 is between 1 and 10. So 3.5 times 10 to the, looks like if it started here and I'm moving it 1, 2, 3, 4 times, that would be 3.5 times 10 to the 4th power. We can also rewrite very, very small numbers. The process is the same. Here is where the decimal place currently is. I need it to be here so that I have 3.9, because 3.9, that significant figure, is between 1 and 10. That means I'm moving the decimal place 1, 2, 3, 4 times, so I have 3.9 times 10 to the, not to the 4th though, but to the negative 4th, because I made a very small number appear bigger. So the exponent of negative 4 tells me that we're actually dividing 4 times in order to move it to the left. All right, and at number 4, 1, 2, 3, 4 times to move that decimal place. So 7 or 7.0 times 10 to the negative 4th power. Feeling pretty good? All right, then I want you to check real quick, make sure that you also know how to write them in standard notation if they're in scientific notation. Do we need another pause break, or are we good to continue to go on? Going on? So here's the decimal place. It doesn't appear that there is one, but it's 9 point. And I need to move it 2 times. It says moving it 2 times. Since it's negative, that means I'm moving it to the left, 1 and 2. So 0.09. I'm going to rewrite that so that we can actually see where that decimal place is. 0.09. 8.34 times 10 to the negative 4th. Again, I can see where that decimal place is, but I need to move it 4 times. So 1, 2, 3, 4. I moved it so many times I ran out of digits. So we just need to fill those in with zeros. And I really like there to be a 0 at the beginning. I want to know that we have a 0 in the ones place. 0.1230, and then 834. Feeling good? All right, and now these ones we have positive exponents, so that means I'm multiplying by 10 6 times, which means the decimal place is going to move 6 times to the right. 1, 2, 3, 4, 5, 6. Filling in all of those empty spaces with zeros. And adding in my commas, I believe I have 8,800,000 with the decimal place here at the end. 2.32 times 10 to the 5th. Moving that decimal place 5 times, there's 1 and 2. 3, 4, 5 are filled in with the zeros. And so I have 232,000. That decimal place there at the end. Still feeling pretty good? All right, now we've got some calculations. I have 2 multiplication, 1 division, and 1 addition. So again, let's pause, see what you can do on your own, and then we'll come back together and review. The lack of coffee. Okay, 9.5 times 5. I'm going to use the commutative property because this is multiplication all the way through. So I'm going to use the commutative property and multiply those together first. Also using the associative property. And again, rearranging and multiplying those together. So if I focus first on the 10 to the 3rd times 10 to the 2nd, I'm using my properties of exponents that I reviewed yesterday. And that's going to equal 10 to the 5th power. 10 multiplied by itself 3 times, and then 2 more times means it's multiplied by itself 5 times. And now I can use the calculator to plug in the 9.5 times 5. And 9.5 times 5 is 47.5. I'll rewrite that. And 9.5 times 5 is 47.5, coming all back together. Is this in scientific notation? No. If you stopped here, you haven't answered the question. It does want our answers in scientific notation. My significant figure is here in red, 47.5, and that is definitely not between 1 and 10. And since 47.5 is not between 1 and 10, that means I need to move the decimal from where it currently is so that it is between the 4.7, or the 4 and the 7, making it 4.7. But now, since I'm moving this decimal place, that means something needs to change with this exponent. That exponent is going to go, yes, Luis. You don't know. I thought your hand was up. What's going to happen with the exponent of 5? Is it going to go to a 6 or is it going to go to a 4? Discuss at your tables. That was almost unanimous. There was no discussion. You all just said 6. Why is it 6? Tell me what your thought process is. Joshua. Yeah, exactly. 47 is getting smaller to go to 4.7. So that means we have to account for that in this exponent getting bigger. All right. We're good on time. Let's just keep on going. Same ideas for each of these. I'm going to multiply the 2 and the 1.4, rearranging using commutative and associative properties to do that. I'm going to multiply the 10 to the 6th power by 10 to the 6th power. This part, I realize, is going to simplify to be 10 to the 12th power. 2 times 1.4, I can type in my calculator. Maybe I can do that in my head. And 2 multiplied by 1.4 is 2.8. Is this in scientific notation? Yeah, this one is. 2.8 is between 1 and 10, so we're good on this one. Division is going to work the same way. So 2 divided by 2.06, going to focus there. And then 10 to the 6th divided by 10 to the 3rd. In my calculator, I would type in 2 divided by 2.06. That one's a pretty number, isn't it? 0.97087. I'm just going to stop there. Times 10 to the 6th divided by 10 to the 3rd. When I'm dividing, I subtract those exponents. So 6 minus 3 is 10 to the 3rd power. I know that there's more decimal places, but we really don't need all of them. In fact, when I rewrite this answer, I might even decide to get rid of some of them. And is this in scientific notation? It's not. 0.97 is not between 1 and 10. So I need to move it over so that it is. So this is going to become 9.7. I'm not even going to worry about the rest of those. 9.7 times 10 to the, what's going to happen to that exponent? 2nd power. Yeah, because the small number got bigger. So to account for that, that number needs to get smaller. And this addition one is also super fun. You might remember, in my general classes, we did not do addition and subtraction, so you don't need to worry about this. In my other class, we did. So I still want us to practice this. When we add or subtract, we always need to line up the decimal place. And when I say we need to line up the decimal place, I'm not talking about the 4.7 and the 2.8, because what we also need to take into consideration is the fact that this decimal place is moving 5 times, while this decimal place is moving only 3 times. So they're not lined up like this, which means I want to get them lined up, so I need to make these be the same. The order of magnitude needs to be the same. We can change them both to 5. We can change them both to 3. Let's just take a vote. Who wants to change them both to 5? Who wants to change them both to 3? Great, let's do that then. So this one is already 3. It's fine exactly the way it is. This one I need to change to be 10 to the 3rd power. Let's look at what's happening. That exponent is going from a 5 down to a 3. So it's going down, which means this number needs to go. Yeah, we're moving it to the right. It needs to get bigger by 2. 4.7 becomes 470.0 times 10 to the 3rd. Add that to 2.8 times 10 to the 3rd. And now that those decimal places are lined up and the order of magnitude is the same, we know that they're going to stay lined up even if I adjust them into standard form. And now we just add 0 plus 8 is 8 in the tens place. 0 plus 2 is 2 in the ones place. 7 in the tens place and 4 in the hundreds place. So 472.8 times 10 to the third power. Is this in scientific notation? No, so we've got to still move that decimal place back to 4.72 times 10 to the fifth power. Okay, let's move on to Pythagorean Theorem. This one, it might look familiar. This one we did for our quick pull. So I'm not going to do that again. We already did it on our quick pull. You can just copy down your work for that one. So I'm going to look at the different types of problems here, and then I'll let you guys work. We already reviewed Pythagorean Theorem with our quick pull, so I'm not going to spend a whole lot of time doing that. But this is all Pythagorean Theorem, where I need to understand I'm using leg squared plus leg squared is equal to the hypotenuse squared. We're finding missing side lengths. So the first several problems, we're finding the side length, rounding to the nearest tenth. On 5 and 6, it actually says leave your answer in simplest radical form. So let's go back to our quick pull. Remember when I did this, I ended up with x is equal to the square root of 200. Let's review simplifying radicals. I don't want us to just type this into the calculator this time. I want us to actually simplify the radical, which means I need to find those factors of 200. That's going to be 2 and 100. 100 is 10 times 10. And I'm going to stop right here because I found a pair. Is this coming back to you? Square root of 200 is equal to the square root of 2 times 100, or the square root of 10 times 10. This can be then broken up into the square root of 2 times the square root of 100, or the square root of 10 times 10. And the square root of 100 simplifies to 10. Typically, we like to write this in the front, so just rearranging that would be 10 square roots of 2. So I'm going to leave 6 for you guys. You guys can practice 6. I think you're also going to be just fine practicing 1 through 4, so I'll do a pause break and let you guys do that. But before we do that, I want to look at the last type of problem. On 7 and 8, it's asking to figure out if it is a right triangle. So I have given you all 3 side lengths. You need to plug in those side lengths to see if they work with the Pythagorean theorem. One thing that you need to understand about the Pythagorean theorem, the hypotenuse of a triangle, the hypotenuse of a right triangle is always going to be the longest side. So when I'm looking at these, trying to decide which one could possibly be the hypotenuse, this one is the longest side, so this is the one that we would have to suppose is the hypotenuse, making the other 2 the legs. And we're just going to plug it in. 12 squared plus 9 squared, is it equal to, I'm asking the question, is that equal to 17 squared? 12 squared is 144. 9 squared is 81. And again, I'm asking, is that equal to 17 squared? And 17 squared is equal to 289. 144 plus 81 is actually equal to 225. So is that equal to 225, 17 squared? No. So is this a right triangle? No. If it were a right triangle, the Pythagorean theorem would have worked. So my justification is no, the Pythagorean theorem did not work. All right, so we've got some practice on this pause break. 1 through 4, you're just going to use the Pythagorean theorem to find the missing side length, rounding to the nearest 10th place. 6, you're going to find the missing side length, rounding, or not rounding, but simplifying to the nearest simplifying the radical completely. And number 8, testing it out to see if it is a right triangle. Go ahead and work on those problems during this pause break. Ready, set, go. Okay, I have identified that this is the leg. and this is the leg, and this is the hypotenuse. So plugging this into the Pythagorean theorem, I have 4 squared plus 14.5 squared is equal to the hypotenuse squared, which is x squared. When I simplify this, I can plug all of this directly into my calculator. I can also simplify it by hand, or piece by piece. 14.5 squared is the only one I need to calculate. That is 210.25. Adding those up together, I have 226.25 is equal to x squared. That tells me what the hypotenuse is when it is squared. I need to unsquare it, so I need to take the square root of each side. Again, using the calculator for this. Well, let's see. Square root of 226.25 means x is equal to 15.0416. Rounding to the nearest tenths place means I need something here, and the 4 is not enough to make that go up. So the length of this hypotenuse is 15.0 inches. Number 2, I have a leg and a hypotenuse. So the first leg is actually unknown, that's x squared. The second leg is 9.6, so that's 9.6 squared. Add those together and it's equal to the hypotenuse, which is 15 squared. So again, just simplifying this piece by piece, 9.6 squared is 92.16. And that is equal to 15 squared is 225. Again, like our warm-up, I need to solve for x, so I need to subtract 92.16 from each side. Getting closer to getting x alone, x squared is equal to 132.84. And I take the square root of each side. That leaves me with x is equal to 11.5256. Again, I need I need something in the tens place, and this 2 is not enough to bump that up, so x is equal to 11.5 inches. I think we'll leave the rest for practice on your own. An answer key has been provided and is linked in the calendar, so you can check your answers, but I'm going to make you do 3 and 4, 6 and 8 on your own for homework. That's it for today. Thanks for watching. We'll see you next time.